Hi, Mr. Murphy here again, and we're going to look at the fourth and final step in the transformations, which is enlargement. Now, as with the rest, if we need to do an enlargement, we need to isolate the idea and the format as to what we're trying to do. So there are set things we're looking for when we're looking to enlarge. Obviously, the first thing is it's either getting bigger or smaller. Okay, if it's bigger or smaller, that is both an enlargement. Okay, and hopefully by the end of this video you'll understand what that means. Okay, the enlargement from that point is the enlargement is done in a scale factor. Okay, so that's how many times bigger or smaller is it than the actual original shape. So if you are doing a scale factor of 2, okay, then that is twice the size. Okay, so that's twice the size. If it's a scale factor of 3, 3 times the size. If it's a scale factor of a half, half the size. Okay, so let's have a look at this initial shape. We've got this shape on the grid. We don't have any points, we're not given any coordinates at all, but it does say to us to enlarge the shape using a scale factor of 3. So if we're thinking about this particular shape, we have got 1, 2, 3 squares along, 1, 2, 3 squares down. Okay, so we need to have a cross that's 3 squares by 3 squares. Now, it doesn't matter where we pick. Let's say we're going to pick this square here. Okay, that's going to be my middle square. Now that's 1 square wide and 1 square across. Okay, 1 square deep, 1 square across. So instead of being 1 square by 1 square, that's my original square. Okay, remember we want it to be a scale factor of 3. So we're going to say 1, 2, 3 squares down, and we're going to go 1, 2, 3 squares across. So that's a 3 by 3 square. Okay, so that is the representation 3 times the size of that 1 square there. Let's look at this middle bit. So we've got this square here. We know it attaches to that square and it's going to be the same size. So we've got 1, 2, 3 squares along, 1, 2, 3 squares down. And hopefully you can see that that square is 3 times bigger than the representation of that square there. Let's, in this colour, let's just pop one up on the top. So we've got another square at the top, 3 squares by 3 squares by 3 squares. Okay, and another one on the bottom, 3 by 3 by 3. Okay, so we've now done the 3 middle squares. Now, just as a check, we do know that that's 3 squares high, as we said originally. So 3 times 3 would give me 9 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Okay, and then I could put this final square on the opposite side in the middle. And bear in mind, I do want to make that, shape being that cross, so I know what sort of shape I'm after. Okay, I need to make the cross that's coming out from the side of that. Okay, so I'm going to come across 3 more squares, down 3 more squares, and there's my final piece to make that cross. and that would be three squares, 3 times the size of the original one. Okay. So we're talking linear measurements for your scale factor. Okay. Don't fall into the trap of thinking, well, I started off with 1 square, and I've now got 9. This was 1 square, and that block there is actually 9 squares. Okay. The area would be 9 squares, but the linear measurement along the sides is 3 times bigger. There's 3 squares there, there's 1 square there. Okay. So what I'm going to say is, let's do a different one, and let's just change the format. So let's say we're going to do one that is a scale factor of 2. Okay, if you want to pause the video and give it a go, okay, see if you match the same as mine. Okay, so let's see how you got on. So we're going to do a scale factor of 2 this time. Remember, I've got 1 by 1, so my scale factor is going to give me 2 by 2. 2 by 2. 2 by 2. And the bottom square, 2 by 2. And then just match up where I started. And you can see there I've got now 2 times bigger than I started. Same shape and just twice as big. Brilliant. Okay. It does get slightly more difficult when they then say you've got to do it from a set point. So we would have a centre of enlargement, and on this one we're doing a scale factor of 3 like we've done before, but this time we would have a centre of enlargement, and that's going to give us, they give us a coordinate 6, 0. So we're going to go, remember, along the corridor and then up the stairs. So 6 squares along gives me to there, and then 0 up, so I still stay. That's my centre of enlargement. So from that point, I need to now make my shape 3 times bigger than what it is. Now, there's 2 or 3 ways of doing this. Some people use the ray method, and what the ray method does is it takes a line that goes from my centre of enlargement through each of the vertex. Okay, and then we just multiply the amount of squares we are away. Okay, I'm going to try and do that sort of method, but just trying to describe it without drawing the rays on. So from this point, if I think that first point, that first vertex there is 1 square vertically above. Now we're doing a scale factor of 3, so we're going to have to multiply that distance by 3 as well. So we're 1 square away, so my square is going to be 1, 2, 3 squares away. So that point there is my first vertex. I'm just going to change colour for this one so we can see where each point comes from. Okay, we're talking this point here. Now to get to there, I go 2 along to the left and 1 up. So I go 2 to the left and then 1 up. Now what I'm going to do is I'm going to create this, I'm going to multiply this by 3, times both of these by 3. Okay, so 3 times 2 gives me 6, so I'm going to do 6 along, 3 times 1 is 3, and I'm going to do 3 up. So from my centre of enlargement, 1, 2, 3, 4, 5, 6, 1, 2, 3. So that point is going to be my bottom vertex. Okay, I'm going to change my colour again. Let's do blue this time, and let's go for the So let's go for this point there. Okay, that's my top vertex. And now from my centre of enlargement, I'm going to go one along, one to the left, and two up. So I'm going one to the left, and then two up. Now remembering I'm timesing this by 3, so times that by 3 means I'm going to go 3 to the left, and then times this by 3 means I'm going to go 6 up. So from my centre of enlargement, 1, 2, 3, 1, 2, 3, 4, 5, 6. That's my top point. Okay, and hopefully you can see the next one should be relatively straightforward. Okay, I've got this point here is going to be the top point there. Let's just check what we've done with that. We've got 1, 2 squares, times it by 3. There's no movement left or right. We've just gone up by 2, times that by 3. That's going to mean I'm going to go up by 6. So from my centre of enlargement, 1, 2, 3, 4, 5, 6. Okay, I can now draw my shape in. Just connect the dots. Always take care with the diagonals, make sure you're using a ruler. Okay, we're coming along. Okay, and that is my shape. Now, what did I mean by the when I said about the ray method? Okay, the ray method is basically just using the information that we've got, and we take a line from my centre of enlargement. So I'm just going to grab a line. Okay. Okay, and I'm just going to go from this centre point here, drag it through to the centre of enlargement. Okay, at the bottom there. Let's make it a little bit thicker so we can see the line a little bit clearer. Okay. If we go from the centre of enlargement again, but this time we're going to go through a different point. Let's do the top point. And let's do the centre of enlargement again. And this time we're going to go across to this vertex over there. Okay, and hopefully you can see by putting the lines from the centre of enlargement through each of the vertices. Okay, the bottom one would come 3 times the length, so I'm 1 square away, 1, 2, 3 squares away. I'm 2 squares away, so times it by 3, 1, 2, 3, 4, 5, 6 squares away. This one here, slightly more difficult, but thinking if we're just going to multiply it out diagonally, we know it's going to be on the right square because we've gone through the vertex itself with the line. We just need to know the number of squares. So diagonally, we're going 1, 2 squares along. So times that by 3, 1, 2, 3, 4, 5, 6 squares along, and that would be my vertex. And the same on this one, 1, 2 squares away, times it by 3, 1, 2, 3, 4, 5, 6 squares along. So there would be my vertex. Okay. So some people find the ray method easier. Okay. Alternatively, you can just do what we did here and work out the distance to the left or to the right, the distance up or down, and then just multiply it by your scale factor. Okay. On some questions, it may say to you about actually detailing the enlargement down. So it gives you the enlargement, you just then need to work out how many times bigger it is. Okay. Now on this one, it's very difficult. It says a centimetre square grid. Okay, so we know each of these are single centimetres. Okay, we know this is 1 and a bit. Okay, just over a half. We know this is 1, 2, 3, 4 and a bit. Okay, but we don't really know exactly the partial measurement of this square. Okay, so if we try and think about how we can work this out, let's look at the side that we do know. We know this is 3 squares wide, and we know this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 divided by 3, thinking the bigger size divided into that. Remember, the rectangle E is an enlargement of D, so we've gone D to E. So what is the multiplication factor to get from there to there? Okay, you can either think 3 times 3 gives me 9, or 9 divided by 3. That's my scale factor. Okay, so if we're looking for that one, we're looking to initially find out what the scale factor is. Okay, and my scale factor on this one, what's the scale factor of enlargement? It's a scale factor of 3. Okay, let's look at the next one. So, rectangle E is enlarged by scale factor 20 to give rectangle F. Write down the length and width of rectangle F. Now, we've got to think we've gone from D to E, and that's a scale factor of 3, and now go E to F, and that's a scale factor of, let's look up here, scale factor of 20. So we're getting 20 times bigger. We know this measurement here is 9, which goes from there to there. So all I'm going to do is I'm going to take the scale factor that they give me and multiply it by 9. So I've got 20 times 9, which is going to give me 180 centimeters. Now this next part, we're going to make an assumption that that's half a square. 1, 2, 3, 4 and a half. Okay, so I'm going to do 4.5 divided by 3 to get from here to here. Okay, what was the original one? Okay, so 3 goes into that once, remainder 1. 3 goes into that 5 times. So this one was 1.5. Okay, so 1.5, 4.5. Hopefully you've seen where the measurements have come from. Now, am I interested in this, the fact that this one is 1.5? No, that wasn't in the question. What does it want to know? What is the width of my new shape? Remember, my scale factor is 20, so I'm just doing 20 times my 4.5. Well, 10 times 4.5 is 45, and if I double that, that gives me 90. Okay. And if we want to check that, thinking about the way we've just worked that out, let's look at the actual shapes if we wanted to compare the shapes. This one here, the width of the shape is 3, the height of the shape is 1.5. So the width is twice the height of the shape. This is 4.5, 2 lots of 4.5 gives me 9. And then check our answer. We have indeed got 90 is half of 180. So that's correct. Okay, hopefully it made a bit of sense. Let's push forward on the slightly more difficult ones. If I've got a scale factor that's a positive number, it's going to get that many times bigger than where we currently are. Okay, so on this one, the question says draw the enlargement of shape A with scale factor 1/3. So my scale factor is 1/3. And centre of enlargement 1, 1. So it gives me my centre of enlargement as being the point 1, 1. Okay, so let's mark that point for a start. So we're coming along, 1 along the corridor, 1 up the stairs. There's my centre of enlargement. Okay, So let's go back to my shape. We've got we've got 3 squares wide, and we've got 1, 2, 3, 4, 5, 6 squares high. Now what you will find with these shapes is they will be a multiple of whatever the scale factor is. Now if I'm going to make that 1/3 of the size, I'm dividing it by 3. So if you think I've got a full circle and I cut it into 3 pieces, this is what I want. I want 1/3 of the size of what I've actually got. Okay, so if I want 1/3 the size of that, 3 divided by 3 is going to give me 1 wide. That's going to be my base, and 6 divided by 3 is going to give me 2 height. So that's going to be my height, and that's going to be my base. So just to know where I'm currently looking to say where that's going to, what I'm expecting in my question. Now let's pick a vertices to look at. Let's look at this bottom one just here. Okay, we know that's going to be from the center of enlargement, and we've gone 1, 2, 3, 1, 2, 3. Now remember, we've already done this calculation. 3 divided by 3 gives me 1. So I'm going to go 1 square along, 1 square up. That's where that corner is going to go. That vertex is going to go. Let's look at the next corner. I've got 1, 2, 3, 4, 5, 6. 1, 2, 3. So 6 divided by 3 gives me 2. So I'm going to go 1, 2, and then 1 square up. Now I think what I'm expecting it to be 1 square wide. Okay. And then I'm expecting it to be 2 squares high. I don't need to do the other vertex because I know my triangle is going to be 2 squares high. Okay. It will look in exactly the same format in the sense of we're not actually changing the orientation of it, we're just making it smaller or larger. Okay, so that would be a scale factor of 1/3. Okay, now again, if I wanted to, I could insert in a shape, could insert in a let's insert in a line. So let's go from the top point. Okay, and let's drag it down to my center of enlargement. And again, make this one a little bit thicker so we can see the line a little bit clearer. And you will see the line will fit from the top point of my triangle to the top point of my new triangle. Okay. If I put the second line on, let's go to a different vertex. So let's pull this down to this bottom corner. So again, the ray method, it gives you an idea of exactly where that triangle is going to be, and it will fit in to each of those rays. Okay, let's just put the third vertex on so we can see that. Okay, and we can see that it goes to there. So hopefully you can see from the center of enlargement through each of the matching vertices. Goes to each of the corners. Top corner, top corner. So it's a good way to check to see if you got it in the right place. Final one we're going to look at. We've done whole number scale factors without a starting point, a center of enlargement. We've done whole numbers with a center of enlargement point where we're enlarging it from. We've worked it backwards to try and find what the scale factor is, okay, and also enlarging it further. And then we've looked at fractional enlargements. So I'm enlarging it, but to a smaller value. I'm actually shrinking that shape down. Okay, so let's have a look at the final one, which is enlarging a rectangle to a negative scale factor. Okay, so again, think about what we could be looking to anticipate, what we're going to be trying to find. If I said that something was this shape here, and we're given enlarge the rectangle by a scale factor of -2, use the origin as centre of enlargement. So let's just put in what they give us at the minute. And we're going to put the origin in. Okay. And we're going to make it, in effect, 2 times bigger. Okay. The only difference is it is 2 times bigger, but it's -2 times bigger. What does that mean in the context of this question? So we go 1 to the right, 1 up for that vertex. So 1 to the right, 1 up. Okay. Let's do the opposite and double it. So let's go 2 to the left and 2 down. So I've doubled my numbers. My scale factor has been doubled. And I've gone the opposite direction, the inverse. Okay, so we've got that point there, and instead of going 1 to the right, we're going to go 2 to the left, and then 2 down. That's that vertex. So I've gone twice the distance. Okay, let's look at the next point. Let's get another vertex. Okay, let's pick this other one on the bottom here. Now we've gone 1, 2, 3 to the right, 1 up. We've gone 3 to the right, 1 up. Okay, so let's then multiply that by 2. That's going to give me 6, and go the opposite direction, and 2 opposite direction. And this is what I'm interested in plotting. So from the centre, I'm going to go 1, 2, 3, 4, 5, 6, and down to 1, 2, that point there. So if I'm thinking my rectangle was 2 squares wide, my new rectangle, scale factor of 2, would be 4 squares. 1, 2, 3, 4. So we're getting the idea. It's going to be twice as big. Okay, I am going to plot the other 2 points as if I would be doing it fully. Okay, so let's look at the other point. Okay, so this one at the top, we've gone 1 to the right, 1 to the right, and then we've gone 1, 2 up. So we've gone 1 to the right, and we've gone 2 up. So remember, we're going to times that by 2. Okay, so we're going to go 2 to the opposite direction, 4 to the opposite direction. And again, that's the one I'm looking to plot. So from my centre of enlargement, 2 to the opposite, and then 1, 2, 3, 4. And that's my vertex. And my final one, 1, 2, 3, 1, 2. So I've gone 3 that way, 2 up, times it by 2, 6 opposite direction, 4 opposite direction. So from my centre of enlargement, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And again, we can draw that shape in. And what I'm expecting it to be twice the size. Okay, it's gone negative, so it's gone the opposite direction. Okay. But again, if we start thinking about this logically, okay, if we use the ray method, and I went through that point in the opposite direction. Okay, so I'm just going to come away from that a little. Okay, let's go back to that point down there, and then make that hit the top point. Okay, I'm going to make these lines slightly smaller this time. Okay, I'm going to put that to that corner, and this one is going to go blue to blue. And the top one is green to green. Okay. And then the final one we're going to go black. Oops. Black to black. And that goes on the same thing. Okay. The only one we haven't done, we've done black to black, so the only one I haven't done is red to red. Red to red. And there you go. So that's just, it just shows that all of the rays go through the centre of enlargement, and we've gone the opposite direction. So instead of enlarging out this way and making the shape bigger, we've gone the opposite direction, but we've still made that shape, that scale factor of 2 times bigger. It's just gone in the opposite direction. So negative scale factor means it goes in the opposite direction. And I'll catch you on the next one.